Hello viewers, in our previous classes we have discussed the concept of tangents and normals. Viewers, we have seen the application of derivatives in finding out the equations of tangents and equations of normals to a curve at a given point. Clear? Now let us solve some problems based on tangents and normals. So here we have the first problem, and the problem goes like this. The slope of the tangent to the curve x equal to t square plus 3t minus 8 and y equal to 2t square minus 2t minus 5 at the point 2 comma minus 1 is. So we have to find the slope of the tangent. Clear? So here the equations are given in parametric form. The equations are given in parametric form. Now the slope is given by the derivative of y with respect to x. Clear? So this is the slope. Now the slope is defined as in case of parametric equations we have dy over dt divided by dx over dt. Clear? Now let us find the derivative of y with respect to t. So this is 4t minus 2 and divided by the derivative of x with respect to t is 2t plus 3. Okay? Now we have to find the slope at this point. So the slope is the value of dy by dx at 2 comma minus 1 is given by here we'll substitute the value of t. Now what is t? T is the parameter. So t can be obtained by taking either x equal to 2 or y equal to minus 1. So let us first find the value of t. So here we have the point 2 comma minus 1. So x is equal to 2 implies t square plus 3t minus 8 is equal to 2. So we have t square plus 3t minus 10 is equal to 0. Now it is a quadratic equation, so we find the solution of this equation. We'll solve this quadratic equation by splitting middle term. So we have 5t minus 2t and minus 10 is equal to 0. Clear? So here we have t plus 5, here we have minus 2t plus 5 equal to 0. So we have t minus 2 and t plus 5 is equal to 0. So we have t is equal to 2 and minus 5. Clear? Okay. Now if we take y equal to minus 1, here let us see what is the value of t. So 2t square minus 2t minus 5 equal to minus 1. So we have 2t square minus 2t, and we take this minus 1 to the left side. So we have minus 4. Now we divide by 2. So we have t square minus t minus 2 is equal to 0. Clear? Now if we factorize this quadratic polynomial, we have t square minus 2t and we have plus t minus 2 is equal to 0. Clear? So here we have t minus 2 and plus 1 and t minus 2 is equal to 0. Clear? So this implies t minus 2 and t plus 1 is equal to 0. So here we have t is equal to 2 and minus 1. Now we see that only t is equal to 2 is the common value between x and y. Clear? So we take the value of t as 2. Clear? So we take t is equal to 2. So therefore the slope of the tangent to this curve is given by 4 times the value of t is 2. So this is 4 times 2 minus 2, and this is 2 times 2 plus 3. So this is 4 to the 8 minus 2, 2 to the 4 plus 3. So this is 8 minus 2 is 6, and 4 plus 3 is 7. So this is the required value of the slope of the tangent to this curve at this point. Clear? Now if we are to find the slope of the normal here, then the slope of the normal is given by the reciprocal of the reciprocal of the negative of this slope. So we have minus 1 over 6 by 7. So this is equal to minus 7 over 6. Clear? Now viewers, we have the second problem. Find the equation of the normal at the point 1, 1 on the curve 2y plus x square equal to 3. Suppose the curve is, say this is the curve, and we have to find the equation of the normal. Say this is the point P and this is the tangent at this point P, and the coordinates of the points are 1, 1. Then the normal is this line. Clear? So this is the normal, and this angle is pi by 2. So this is the normal, and we have to find the equation of the normal at this point 1, 1, and this is the curve and this is the tangent. Clear? So here's sorry, here we have to find the equation of this normal. So we know that the equation of the normal is given by at the point x1 y1 is y minus y1, x minus x1 is equal to the negative of the reciprocal of the slope of the tangent at the point x1 y1. So here this point is x1 y1. So let us find the value of the derivative or the slope. Okay, so here we'll find, so differentiating 1 both sides. So we have 2 times of the derivative of y with respect to x plus 2x equal to 0. So we have dy over dx plus x equal to 0. We divide both sides by 2. So we have dy over dx is equal to minus x. Clear? Now we have the equation 2, and here we'll substitute the value of x1 y1 and the value of the slope. So this is the slope of the tangent. Clear? This is the tangent. So y minus y1 implies 1 and x1 implies 1. So this is y minus 1 over x minus 1 is equal to minus 1 divided by the value of the derivative at this point. And here we see that it is equal to, because x1 is 1, so the value of this derivative at this point is minus 1. So we put minus 1 here. Clear? So minus minus cancel, so we have 1. So this implies that y minus 1 is equal to, we multiply this x minus 1 with 1, so we have x minus 1, minus 1 and minus 1 get cancelled, so we have y is equal to x, or x minus y is equal to 0. Clear? So this is the equation of the normal. So this is the normal. So the equation of this line is y is equal to x, or x minus y is equal to 0. Clear?